All right, Math 8, here we go. We got lesson 4-5, rotations, day 2. All right, so we're going to take AB and go 90 degrees counterclockwise. So A is going to go spinning this direction 90 degrees. Looks like A is going to be at 4, -5. No, sorry, -4, -5. All right, so it's going to go -4, -5 right to here. That's A prime. Makes sense. It should move one quadrant. So B should also move to this quadrant here. Let's spin it. It looks like it's at -2, -1. All right, so -2, -1, there's B prime. All right, what do we got here? It appears as if I've got this one, the slope. It says compare the slopes and the orientations. This one goes down 2 and right 4. So the slope of AB is -2/4, which reduces to -1/2. And then the slope of A prime B prime goes up 4 and right 2. So the slope of A prime B prime is up 4/2, which reduces to 2/1. All right, so looking at the slopes, comparing them, what we have here is that one of them is negative, one of them is positive. Those are called opposites. And then on top of that, the numerator and the denominator have switched. So we call that a reciprocal. So we notice when we have a 90-degree rotation, the slopes become opposite and reciprocal. The opposite part makes sense because when we're spinning it, the x is becoming y and the y is becoming x. So that kind of makes sense there. Orientation. Orientation, if you look at it really closely, this thing obviously has spun around to over here, but look and see what would happen if we connected these two. Let me spin this paper a little bit. You see how these two, if we connected them, that makes a right angle right there. So the two segments are perpendicular to each other. They're making right angles, which makes sense. I spun it 90 degrees. They should be making a right angle. So we do notice that our two segments there are perpendicular to each other, or they make a right angle. All right, let's rotate AB 180 degrees. So that is 2 spins. 1, 2. A is now at +5, -4. So it has moved 2 quadrants. It's on 1, 2. So that is now at +4, -5. Is that right? No, it's a +5, -4. Because I'm not paying attention. All right, so there is A prime prime. All right, B, we're going to spin it twice. 1, 2. B is now at 1, -2. All right, 1, -2. So 1, -2. Everything's kind of making sense because I have moved 1, 2 quadrants. We're keeping the same distance to the origin there as we spin it around. B is the same distance to B prime, or to the origin, as B prime is to the origin. There we go. Okay, so we already know that the slope of AB was -2/4, or -1/2. Let's look at B prime prime and A prime prime. This one goes down 2 and over 4. So the slope of A prime prime, B prime prime is also -2/4. Okay, so in a 180-degree rotation, the slopes do not change. They are both going to be the exact same slope. It looks like it. Looks like these two are parallel to each other, right? But look at the orientation. Top one's A, bottom one's B, top one's B, bottom one's A. So they have the same slope, but the orientation has switched. So they're facing in the same direction, but the orientation is switched. So the orientation of the points is switched. All right, last one, 270 degrees counterclockwise about the origin. That is 3 spins. We should go 1, 2, 3, so 90, 180, 270. That's where we should end up. So let's follow A as we go through that. 190, 180, 270. A should be at 4, 5, right? So A is at 4, 5. All these papers are all messed up now. So 4, 5. Here's my A. Prime, prime, prime. B, if we spin it, 90, 180, 270. B is now at 2, 1. Right? So B is now at 2, 1. E prime, prime, prime. All right, we already know that the slope of AB is negative 2 over 4. Which is negative 1/2. And now let's look at the slope of A prime, 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 E prime, prime, prime. This one goes up 4 over 2. So we're getting that opposite reciprocal slope again. Just like we had at the 90 degrees, we had opposite and reciprocal slopes. At 270 degrees, we also have opposite reciprocal slopes. And the orientation, yes, these are making 90-degree angle with each other. So this line and this line, they are creating a right angle. They're perpendicular. All right, if we rotate AB 90 degrees clockwise about the origin, what would we expect to find? So if I take this and go 90 degrees clockwise, this should end up here. Well, we should expect this to be this one. Let's see that. Let's do A. Let's spin it 90 degrees clockwise. There's clockwise. A is at 4, 5. And A's at 4, 5. Okay, so B, if I spin it 90 degrees clockwise, is at 2, 1. Let's do B over here, 2, 1. Okay, so if I do 90 degrees clockwise about the origin, that should be the same thing as 90 degree or 270 degrees counterclockwise. We expect to find that it's the same as 270 degrees counterclockwise. So if I go 90 clockwise, it's the same as going 270 counterclockwise. And we saw in previous lessons that 180 degrees doesn't matter which direction you go, counterclockwise or clockwise gets you to the same point. All right, find the coordinate notation for each of the following rotations. So 90 degrees counterclockwise from here to here. Okay, so A was at negative 5, comma, positive 4. Let's look at A prime. That's at negative 4, comma, negative 5. So it looks like the X moved to the Y position. So X moved to the Y position, and the Y moved to the X position, but changed its sign. So that would be negative Y, comma, X. It works for B as well, B is at negative 1, 2. And B prime is at negative 2, negative 1. Look what happened. The X moved to the Y position. So that X moved to the Y position. So X is now in the Y position here. And the Y moved to the X position, but changed its sign. So when we do 90 degrees counterclockwise or 270 degrees clockwise, that would be negative YX. Looking at A to A prime is at 5, negative 4. What we see here is this is negative 5, this is positive 5. This is positive 4, this is negative 4. So when we do 180 degrees, we notice that the X changes its sign and the Y changes its sign. When we do 90 degrees clockwise or 270 degrees counterclockwise, A is at 4, 5. So it looks as if the X moves to the Y position, but changes its sign. And then the Y moves to the X position, but keeps its sign. And this switching position and changing the sign goes back to what's happening with the slopes. Look what's happening to the slopes. They're switching position and changing their sign. So that's what we're seeing in the coordinate notation down here. The slopes were flipping and changing their signs, and here the X's and Y's are flipping and changing their signs. Name another transformation that would give you the same result as a 180-degree rotation. This would be a double reflection. So this would be a reflection over the x-axis and y-axis. Let's show that. So let's say that I reflect over the x-axis. This point would move down to here. This point would move down to here. So that would be our reflect over the x. And then if I reflect over the y, look what happens. This point moves to here, and this point moves to there. So if I reflect over the x, then reflect over the y, that would be the same thing as a 180-degree rotation. All right, last two problems. For this one, we want to rotate triangle XYZ 90 degrees clockwise about the origin. So we're going to go 90 degrees clockwise. That means X is going to show up in this quadrant. Y and Z will show up in this quadrant over here. Okay, so spin it. X should be at 2, negative 1. So here's where X should show up at, or X prime. Y, if we spin it clockwise, should show up at negative 3, negative 1. All right, negative 3, negative 1. Z should show up at negative 2, 5, negative 5. So negative 2, negative 5. Move so you can see it. There's our new shape. And you can really see some of the 90-degree angles that we're supposed to see here. You see this XY? It rotated, and here's XY here. And look, that's making a right angle right there. This line here is a right angle with this line. This line here is a right angle with this line. So that's how we can check to see if our rotation is going correctly. Now this one is rotating 180 degrees counterclockwise. Let's go ahead and use our coordinate notation. The X and the Y just changed their signs. This is negative 2, positive 5. So what's the opposite? Positive 2, negative 5. So L prime should show up over here. This is at 2, 5. So it should go to negative 2, negative 5. using the coordinate notation -x, -y. M is at 3, -3. So that should be at -3, +3. We're just switching the signs, which makes sense. This should move 1, 2 coordinates over there. All right, new shape. Did I do something wrong? I sure did. This was -2, 3. I went -2, 5 for some reason. I don't know why I did that. So this should be -2, -3, or 2, -3. Wow, how did that happen? It's early. All right, trying to pay attention. Like the way that I noticed that something was wrong is I was like, wait a minute, that is not parallel to this one. So you can really tell when you're doing something wrong because I expected this one to face the same direction as this one. And when it was flat like that, I'm like, wait a second, I did something wrong. So knowing what they're supposed to look like is really helpful for checking to see if you're making errors when you do this. All right, keep on mathing hard. I will see you guys later. Bye-bye.